Okay, so section 4.4 has two really important, huge topics. The first one is the Pythagorean theorem. We're going to do that one today. The second big topic is the distance formula. We're going to do that one tomorrow. We're going to review them both on Friday. Friday we have shortened classes for Veterans Day Assembly, so just be ready. I don't know the schedule. I'll try to get a copy of it by tomorrow, hang it up so you can see it. So Pythagorean theorem today, distance formula tomorrow, review Friday, shortened period because of the assembly. All right? Yes, the Veterans Day one.
This is to enact two students.
All right, so this is the Pythagorean theorem. I wouldn't necessarily write down the thing right under that, the little paragraph, but I'll read it for you. It says, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So you could write it as hypotenuse squared equals leg squared plus leg squared. More commonly, it's written as a squared plus b squared equals c squared. Now, c has to be the hypotenuse. You've definitely seen this before. C has to be the hypotenuse. The hypotenuse is always the longest one. It's always across from the right angle. Yes, go ahead and draw that. The legs are interchangeable. It doesn't really matter which one you call A, which one you call B, because you end up squaring them and adding them together. But the A and the B are the ones that make the right angle. So those go together. And then across from the right angle, that's where the C is located. That's the one that's always on the one side of the equal sign by itself. So once again, it was written like this on the last slide. The more typical way is just a squared plus b squared equals c squared. Remember, A and B are the legs. C is the hypotenuse. Okay?
Hold on, bro. 24. Okay, now repeat what you just said.
So the two sides that make the right angle, that has to be the A and the B. So the side across from the right angle has to be the C. So on this one, it doesn't matter which one you put first, the 24 or the 10, as long as they're on the same side of the equal sign. And then equals C squared.
Come on, guys. I've been right there.
So cool.
Less comments. Let's just
Can I say something real quick? So, are all the equations supposed to have a 2 on top?
yes, everything is squared when you're doing the Pythagorean theorem. So 10 squared is 100. 24 squared is
600.
when you add them, it's 676. Good.
Alright, this. Okay.
Now, everyone practice this step with me because this is where it gets a little more challenging. I am following the yellow calculators. If you have your own calculator, it might be a little bit different. But you hit second. It's the top left green button. And then do you see the x squared right next to the 7 right above it? There's a square root symbol.
Where?
Next to the 7 is an x squared.
So where you get the 100 from?
So hit...
Oh, I see it.
Hold on one second. So hit second and then x squared. It should bring up a square root symbol.
Oh, alright.
Okay? That's where you type in the 676 and hit the equal sign. What we are doing is taking the square root of both sides. That's how you undo squaring something. So what is C? 26. Okay, now back up a few steps before that. If you have questions, we squared the 10 to get 100.
Wait, hold on.
We squared the 24 to get 576. We added them together to get 676, and then I did the square root on the calculator.
Alright, hold on.
So since that side that we're looking for is across from the right angle, that's the one that has to be by itself.
Alright.
The 7s make the right angle, so those are my A and my B. So 7 squared plus 7 squared
Wait.
equals C squared. What is 49 plus 49?
98.
98 equals c squared. I don't want to know what c squared is. I want to know what c is. So to undo squaring something, we're going to take the square root of both sides. So that's where you hit the second x squared button. It'll bring up a radical. Type in 98.
What's the second?
It's the top left button. It's like green.
Alright.
Now,
Or 9 point.
if your calculator is not on the right setting, it will give you your answer with a square root still in it. Okay? Mine is doing that now, so I'm going to have to change it. It's just, I'll just come and change it for you. It doesn't take too long. But then once you change it, you can try it one more time. And what does it give you?
9.89.
9.89. So we're going to round that to the nearest tenth. So 9.9. So how should I start the equation for number 3?
14 squared
14 squared plus
plus 9.
9 squared equals c squared.
Oh no, don't go too fast.
All right, so what is 14 squared?
196.
196. What's 9 squared? 81. All right, when you add those, you get 277. That's when you do that square root. So second x squared will bring up your square root. 277.
16.6.
16.64, so we'll round that to 16.6.
So how come the one in the middle has the C like at the end?
So on number 4, we're looking for B. So these are a little harder when you're looking for the legs. There's one extra step in the process of solving these. Which one's going to be the A? The A. 11. So I'm going to have 11 squared plus B squared equals 23 squared. Again, the 23 has to be the C because it's a cross. All right, so 11 squared is 121 plus B squared equals 23 squared is 529. Now this step is where it gets a little harder than the last ones, because here we have to subtract 121 from both sides before we take the square root. You got to get the B squared part by itself before you take the square root. Okay, so when I subtract 121 from both sides, I'm getting that B squared, you are correct, equals 408. Now I take the square root. So second x squared. What are you getting? 20.19. So that would be 20.2 when you round to the nearest tenth. Good. Questions? All right. Number 5. How should I start it?
24 squared. Wait, number 5. I'm thinking we on 26.
So I'm looking for the A, right? So A squared plus 8.4 squared equals
11.9.
11.9 squared. All right, so we have A squared, 8.4 squared. Now I'm not going to round till the very end, so I'm going to keep these with 2 numbers after the decimal. I'll round to the nearest tenth at the end. All right, what am I going to do before I take the square root? Subtract. Good. You got to get that square root by itself.
Why is subtracting for?
Because I have to get the A squared part by itself before I can take the square root. That's how this, when you're looking for one of the legs, it's a little different. It's just an extra step.
Wait, you gotta do that because
The reason we have to do it on this slide and we didn't have to do it on the previous one, previously the variable was already by itself because it was the C. Here the variable is not by itself because it's one of the legs. So you got to subtract the other leg from the hypotenuse after you square them all. Then you can take the square root.
What time we leave?
55.
All right. Anyone have the answer for me?
No.
8.4.
8.42, so we'll keep that as 8.4.
A squared.
A squared plus,
Hold on.
23 squared.
careful.
24.
Yeah, the 26 has to be our C because it's across from the right angle. That guy.
Equals 26. Hold on.
All right, so I need to do 24 squared
Plus
576.
and 26 squared.
You subtract 576. Oh my God.
First-
5.0 something.
First, I have to do 26 squared.
676.
676. Good. This one's going to turn out nicely because when you subtract, what do you get? What's 676 minus 576? 100. And when you take the square root, what do you get? Careful. What number times itself gives you 100?
10 times 10.
10. So yes, A is going to be 10. Good.
I still don't know how to do this square root. Okay.
I'll show you in just a second. All right, so real quick, today we learned,
Something theorem.
yes,
Something theory.
I don't know how to say that word.
Pythagorean.
all right, so today we learned the Pythagorean theorem. That's your summary. Like I said at the beginning, we are going to learn the distance formula tomorrow. It is very closely related to Pythagorean theorem, and then we'll review to finish out the week.